Standard form of a quadratic equation or parabola looks like this. The x squared term first, the x to the first term second, and the number or the constant third. And no a, b, and c. A has to be in front of the x squared, b is in front of the x, c is in front of nothing. So it's just a constant. Standard form means in that order. So the x squared term should be first, x to the first term second, and the constant last. Okay, for the axis of symmetry, that means it's the actual symmetrical line that is not shown on the graph, but a parabola always has a line of symmetry right down the middle. There's your vertex. Okay, so for the axis of symmetry, it's a vertical line, and that's the reason it says x equals, because it's a vertical line. Okay, the formula is negative b divided by 2a. So b is the number in front of x to the first, a is the number in front of x squared, and you just plug it right into that formula. That's going to get you a line that you're going to graph, and that's your line of symmetry. So make sure you wrote that formula down in your notes. Let's just go through and identify a, b, and c. A on this first one, y equals x squared, is a 1. There's no x term, so b is 0, and c is 0. When I do the negative b over 2a, I get negative 0 over 2 times 1, which is a 0. Number 2, a equals 1, b equals 0, and c equals 2. But my negative b over 2a is still going to be that, so it's still 0. What that means on those first two is my line of symmetry is the y-axis. So I'm going to go ahead and trace that, because I do want to eventually draw in my line of symmetry. So I'm going to go ahead and put label AOS, because we're going to end up graphing, and I want to use that AOS. It's going to help me graph. And then the third one, a is 1, b is 2, c is negative 1. So when I plug in my formula, negative b, which would become negative 2, over 2 times a, which is 2 times 1, and I simplify that, my axis of symmetry is negative 1. Remember, those are x equals negative 1. So I'm going to go out to x equals negative 1, and I'm going to make a line, so just 1 unit over from the y-axis, right, is my AOS, and it's at x equals negative 1. Okay, so we've got our line of symmetry where our parabola is going to be around. Let's go down and figure out how to find where to graph it. So I'm going to go ahead and just fill these in. These are the answers we just got up above. So we know the axis of symmetry on all three of these. To find the vertex, that's going to be that middle point, that point that's either the highest or the lowest on a parabola. So it's always going to end up on the axis of symmetry, which means it's going to have the same x value. So we've already found the x value to all of our vertices, I should say. So I'm going to take that 0, and that's going to become my x value. And then to get the y value, I'd plug it into the equation. So y equals x squared would be y equals 0 squared, which is 0. So I'm going to go backwards. I'm going to ignore these graphs here. And I'm going to go ahead and plot the point 0, 0. So go ahead and do that with me, please. There's our vertex. Now we need to find 2 more points, at least. And I think we'll be done, because if I plug in another point now, I'm going to copy my formula down here. So this is y equals x squared, the first graph. So if I plug in another point, so maybe the number 1 for x, Well, if I plug in 1 for x, what's 1 squared? 1. So there's another point that I can grab. So I'm going to go back up here and plot the point 1, 1. Since I have an axis of symmetry, I'm going to use it. So 1 unit to the right of the axis is my point. I'm going to go 1 unit to the left of the axis and put another point. So basically you plot it and then you reflect it. Let's find one more point. So click another point to plug in. I'm going to plug in 2 for x. If I plug in a 2, I get 2 squared is 4. And I'm going to plot that point. So 2, 4. I'm going to plot it and then I'm going to reflect it. So 2 units to the right of the axis would become 2 units to the left of the axis. I've got 5 points. Let's say that's good because that's enough to make my nice shaped parabola here. So I'm going to go by the rule of thumb, 5 points total. And that includes the vertex. You are more than welcome to plot more than that, but that's enough. Okay, second one. So let's go down to where I was doing the vertex. So I'm going to take that 0, and that's going to become my x value of the vertex. When I plug it into the formula, x squared plus 2, I get 0 plus 2, which is 2. So my vertex on the second graph is 0, 2. So 0, 2. And then we're going to do the same thing again. So this was my formula that we're using, my quadratic equation. And let's pick another x value to plug in. So we've already done 0. Let's do 1. So if I put 1 squared plus 2, I get 3. So I'm going to plot the point 1, 3. And then I'm going to reflect it. So 1 unit to the right becomes 1 unit to the left. And I'm going to do the point 2. 2 squared is 4 plus 2 is 6. So the point 2, 6, which is 2 points. I'm sorry, 2 units from the axis. So I'm going to go 2 units to the left of the axis. And we've got enough for our parabola. All right, last one. I like this one because it's a little bit moved over. It's not on the y-axis anymore. So we already know that AOS is -1. That's going to become the x value of my vertex. Okay, so I just move it down, plug it in. So -1 squared is 1. 2 times -1 is -2 minus 1. So 1 minus 2 minus 1 is -2. There's my vertex. So -1, -2 is my vertex. All right. So we've got a little bit longer formula here to work with. We have to pick some other points to plug in. We haven't plugged in 0 yet because 0 wasn't our part of our vertex. So let's definitely do 0. That's easiest. So if I plug in a 0 for x, I get -1 for y. So there's that point, which is 1 to the right. So I'm going to go 1 to the left of the axis. And then I'm going to plug in 1 because 1's pretty easy. So +1. So 1 squared is 1. 2 times 1 is 2. 1 plus 2 is 3. Minus 1 is +2. So 1, 2. Plot it and reflect it. And there are 5 points. And there's our parabola. Okay, one last thing about parabolas is minimum and maximum. Every parabola has one of these. They either have a minimum point or a maximum point. Looking at a graph, it's kind of easy to see. Because if a parabola opens up, it looks like a U. Well, I'm putting those arrows on top because it keeps going up. up, 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 up forever. It doesn't keep going down, so it's got a minimum point. Same thing with if it's upside down. It looks like this while it continuously keeps going in both of those directions, so it has a maximum point. So how do you know? By looking at the equation. If you don't have the graph in front of you, well, if A is negative, it makes it open upside down, so that becomes the maximum point. Your vertex is going to be the maximum point. So if A is negative, I should have made a, so A is negative, so it's going to be a maximum point. If A is positive, then that means it's U-shaped, so it's going to have a vertex that is the minimum. And you don't have to be this detailed if I asked you, you just have to say minimum.